Here we have a pre-calculus question. Okay, let's go over the question. The graph of y equals to f of x is shown below. The graph of y equals to square root of f of x is to be drawn on the same coordinate plane. Okay, so here we have the parabola for the graph of y is equal to square root of, y is equal to f of x. Okay, let's go with the other information here. The graph of the function y equals to square root of f of x will have a domain dash, and there are dash invariant points associated with this transformation. So we have 4 options over here. Okay, now let's consider the graph of the given function y equals to f of x. Okay, here it's a parabola. So then the f of x must be a quadratic function, because only for quadratic function we'll have the graph parabola. Okay, to get the function f of x, what I need to do is I have to consider the 2 x-intercepts of the given parabola. So here the first x-intercept is negative a, and the second x-intercept is positive b. Okay, to get the factor corresponding to this x-intercept negative a, so I have to write first x equals to negative a. So to get the factor corresponding to this x-intercept, I have to make the right side 0. So for that, I have to add a to both sides. When I add a to both sides, negative a positive will cancel, I get x positive a equals to 0. So this is a factor. X positive a is a factor corresponding to the x-intercept negative a. Okay, the same thing we have to do for the second x-intercept b. So x equals to b. Now let me subtract b from both sides. The positive b, negative b will cancel out. I get x negative b equals to 0. So x negative b is a factor corresponding to the second x-intercept b. Okay, using these two factors, we can write the given function y equals to square root of y is equal to f of x. So we have y is equal to, so for f of x, we can write we can write f of x in terms of these two factors, x positive a and x negative b. Then we get x positive a times x negative b. And also, please make sure this must be a quadratic function, because the graph is parabola. Okay, when I multiply x and x, I'll be getting x square. So since I'm getting x square over here, it is a quadratic function. So so the function what I got for this, the graph is correct. So at the same time, so there must be some constant over here. So we can assume there's some constant k over here. Since the parabola opens up, the leading coefficient of the quadratic function has to be positive. So that means when I multiply this one and this one, I'll be getting x square as the first term. And when I multiply this x square by this k, I'll be getting kx square. So here the leading coefficient is k. So k must be positive, because the parabola opens up. Whenever the parabola opens up, the quadratic function, the leading coefficient, the coefficient of x square has to be positive. Okay, so k has to be greater than 0. So we can assume any value for k, any positive value for k. Okay, now let me assume a positive 1 for k. So that will be easier for me to proceed the problem further. So we must have a positive value over here. So I assume positive 1. So 1 times everything will be still the same thing. So the quadratic function which represents a parabola over here is y equals to x positive a, x negative b. That is for f of x, we have x positive a times x negative b. Okay, now so what we do, we have another function that is y equals to square root of f of x. Okay, let me write that function over here. So we have y equals to square root of f of x. Okay, y equals to square root of, for f of x, we got that x positive a times x negative b. Okay, so here we have y is equal to square root of x positive a times x negative b. Okay, so this is a square root function. So whenever we want y to be defined in a square root function, the value inside the square root has to be either 0 or greater than 0, because if this value is negative, then it will become imaginary, then y is undefined. So to get the domain of a square root function, so always we have to take the stuff inside the square root has to be equal to 0 or greater than 0. So here the stuff inside the square root is x positive a times x negative b. It can be equal to 0 or greater than 0, so that y is defined. Okay, so to solve this inequality, to make the process of solving this inequality easier, so what I'm going to do is I'm going to assign some value for a and b. So here when I look at the graph over here, a is a little far away from the origin than b. So but b is little closer to origin. So I assume a equals to 2 and b is equal to 1. It's just my assumption. Let a is equal to 1 and b is equal to, a is equal to 2, sorry, and b equals to 1. Okay, now we can plug in a equals to 2 and b is equal to 1 in this inequality. Then I'll be getting x positive 2 times x negative 1 greater than or equal to 0. Okay, now to solve this inequality, first initially we can assume this inequality as equation, then I'll be getting x positive 2 times x negative 1 equals to 0. So if so when I solve this equation, I'll be getting x equals to negative 2 or x equals to positive 1, because when I plug in x is equal to negative 2, it becomes 0. When I plug in x is equal to 1, it becomes 0. Okay, so I got two values for x, negative 2 and positive 1. Let's mark these two values on the number line. So on the left side extreme we have negative infinity and we have negative 2, positive 1, and the right side extreme is positive infinity. Okay, here, so let's consider, okay, we have three intervals, negative infinity to negative 2, negative 2 to positive 1, and 1 to positive infinity. And here x can be negative 2 and x can be 1, because when I plug in x is equal to negative 2, it will become 0, 0 times everything 0, 0 equals to 0. It's not only greater than, it's greater than or equal to. So this step can be equal to 0. So x can be equal to negative 2, and also x can be equal to 1, because when I plug in x is equal to 1 over here, so 1 time 1 negative 1 will become 0, so 0 equals to 0. Okay, anyway, so let's check out of these intervals which one works with this inequality. So for that, let's take a random value on the first interval. So I'm taking negative 3 in the first interval. So when I plug in x is equal to negative 3 into this interval, what will happen? So when I plug in x equal to negative 3, the value of this factor will become negative 3 positive 1 will become negative 1. And when I plug in negative 3 over here, it will become negative 4. So negative 1 times negative 4 will become positive 4. Positive 4 greater than 0 is true. So the first inequality works. I mean, this inequality works. Okay, now let's take a random value the second interval, that is between negative 2 and positive 1. I think I can consider 0. If I plug in x is equal to 0 over here in this factor, 0 positive 2 will be 2. And if I plug in x is equal to 0 over here, it's negative 1. So 2 times negative 1 is negative 2 greater than or equal to 0 cannot be accepted, because any negative value can now be greater than 0. So the second interval does not work. I mean the interval negative 2 comma 1. Okay, now let's take the third interval, that is 1 between 1 and positive infinity. Let's take a random value over here, that's 2. So 2 positive 2 will become 4, 2 negative 1 will become just 1. 4 times 1 is 4. 4 is a positive value greater than or equal to 0 can be accepted. So this interval also works. So, and I've already told you that negative 2x can be equal to negative 2, because when I plug in x equal to negative 2, it becomes 0. 0 greater than or equal to 0 can be accepted. So x can be equal to negative 2 or it has to be less than negative 2. Otherwise, x can be equal to 1 or greater than 1. So these are the two solutions we get for this inequality. But we don't have positive 2 or negative 1 in the actual inequality. We have positive a, negative b. So to make the solving process easier, we just assumed 2 as a value for a and 1 as a value for b. So now let me take these two inequalities, that is x less than or equal to negative 2 and x greater than or equal to 1. Okay, now we can replace this 2 by the original stuff. So actually we have a. So for 2 we have a. So this 2 can be replaced by a. So we get x less than or equal to negative a or x greater than or equal to. For this one we can plug in b. So x greater than or equal to b. So when x less than or equal to negative a or x greater than or equal to positive b, so in the function y equals to square root of x, y is defined. So for this square root function, that is y equals to square root of f of x, so the domain is x less than or equal to negative a or x greater than or equal to positive b, where a and b are real numbers. So we find this of x less than or equal to negative a and x greater than or equal to positive b in row A and row B. In both the rows we find, so this one. So which one can be correct? So for that we have to check with the second blank, to answer the second blank, because that is we have to find the number of invariant points, because row A says there are 4 invariant points and row B says there are 2 invariant points. So we have to find the invariant point so that we can decide so whether option A is correct or option B is correct, but I'm pretty sure option C and option D are incorrect. Okay, now so to check to check whether A or B is correct, so we have to find the number of invariant points. So for that we have to graph the transformed function, that is y equal to square root of f of x. Okay, when I look at this function y equals to square root of f of x, so what sign do we have in front of this square root? Actually we don't have any sign, so we have to assume there is a positive sign. So in this function always y is positive. So when I sketch the graph of this function, we'll have the graph above the x-axis. So because below the x-axis, the y values will be negative. So here y equals to positive square root of x. And also to graph this function, we have to consider the domain. So the domain is, the first part of the domain is x less than or equal to negative a. So here we have negative a. X less than or equal to negative a means we have to consider the values of x on the left side of negative a. At the same time, the graph of this square root function has to be above the x-axis. Okay, so the graph may be like this. So the first branch. And now let's go to the second part of the domain, which is y is x greater than or equal to b. X greater than or equal to b means we have to consider the values of x on the right side of b. So the second branch of the graph of this function y is equal to square root of fx will be there. Okay, now how many points the graph of this function y equal to the square root of f of x and the original function y is equal to f of x intersect. So here, so the graph of y equals to square root of f of x and y equals to f of x intersect in 2 points. So the parabola is the graph of the original function. And here the graph of y equals to square root of f of x and the original function y equals to f of x intersect in 2 points over here. So the original graph, the parabola that is represented by the function y equal to square root of y is equal to f of x, and the graph of the transformed function y equals to square root of f of x are intersecting in 4 points. Actually, invariant point is the point we have on the graph of the original function and the transformed function as well. So that point must be on both the graphs. So here the 4 intersecting points are this one, this one, this one, this one. We have these 4 intersecting points on the original graph parabola and the graph of the transformed function y equals to square root of f of x as well. So these 4 points are considered to be invariant points because we have these 4 points on both the graphs. So the number of invariant points are in 4. So in option A, we have 4. So this represents the number of invariant points associated with this transformation. So already we got this one as domain. So the correct answer choice for this question is option A.